Hello, and this time we're looking at direct proportion calculations. And direct proportion is when one thing gets bigger and the other thing gets bigger in the same proportion by the same amount, okay? So it's kind of like an enlargement where, if it gets twice as tall, it gets twice as wide. It's the same thing. And these, if you were to draw a graph of them, they would go through 0, 0, and they have a straight line relationship. So these things don't have to be the same. It's just that whatever this value might be, if you double that value to there, then you have also doubled that value there. Okay, if you times it by 1.4, then the other one is 1.4 times bigger. And if we know that we have this direct relationship, then we can calculate a missing value. So these are kind of like ratio questions, kind of like enlargement questions. You can think about them in different ways. The maths is always the same no matter what you do. It's just how you think about it. So 7 litres of petrol costs this amount. What's the cost of 35 litres? Let's do the ratio method. So put it as a ratio, 7 to 7.91. Now I know this doesn't really work as a ratio because, shouldn't be different units and things like that. But what we're saying is the number 7 is related to 7.91, and that's going up to 35. So it's not a real ratio, but, just think about it in these terms. If you were going to make an equivalent ratio, what have you done here? Well, you've times that by 5 to get it up to 35. So all we have to do is times this by 5, and that will tell us the cost. Nice and easy. You can also look at it as a scale factor problem. You can say, what do I scale factor between my 7 litres and my 35 litres? It's a scale factor of 5, and so just apply the same scale factor to the cost. But you're essentially doing the same thing, whether you think about it as sort of an enlargement scale factor kind of thing, or ratios, doesn't matter. The point is, you're scaling one up, you scale the other by the same amount. Now this is a good question because 7 goes directly into 35. But that's not always the case. So there are 15 cakes in a box and it weighs this much, and now we got up to 25. Now it's not completely obvious what that scale factor is between 15 and 25. I mean, it's not ridiculous, but I'm going to show you just two little methods, one calculator friendly and one if you don't have a calculator. So let's start with the calculator one. It's exactly this method. It's not a new method at all. So 15 cakes, it goes with, so I'm going to do it as a ratio, even though it's not really a ratio, but is equivalent to 420 grams. And the 15 is becoming 25, and we want to know what that number is. So we say, well, what do we times 15 by to get 25? Well, get a calculator or in your head, what is 25 divided by 15? So if you do the divide backwards, it's 5/3. Right, okay. So times by 5/3, it reckons. And we're going to do the same to the other side. We're going to times this by 5/3 as well. Just like here, as long as you times both sides by the same amount, it will stay in direct proportion. So times by 420, and the answer is 700 grams. And although we had a grumpy scale factor here, this enlargement factor, it was a fraction, it came out in the end because this does divide by 3, so that's okay. Now there is another way to do it, which is a bit easier if you don't have a calculator, although it's actually exactly the same once you think about it, but this is called the Unitary Method, which says, okay, well, 15 cakes weighs 420 grams. What does 1 cake weigh? And so you divide both sides by 15, you bring it down to 1. Now in this case, you don't have to bring it down to 1, you could bring it down to 5, because 5 goes into 15, but also goes into 25. So you could bring it down to 5, which is a bit easier. Divide by 3. So we can divide this by 3. What's that going to be? 140, probably. And then times that by 5 to get back up to 25 is going to give us the 700. So essentially what we did was we did the same thing. We divided by 3, we times by 5. It's the same thing here. But it will always work, even if there's decimals, even if there's horrible stuff. The unitary methods say just turn it into a 1 to something ratio. So divide both sides by 15, and we're going to get 28. and that's what 1 will be. So now you can scale it up to 25 by timesing by 25. That will always work as well. But most people find just writing it as sort of pretend ratios that aren't real, aren't meaningful ratios in that respect, how the numbers are supposed to work, but writing it as this number is related to this number, and so this will have the same relationship. And if I scale 1 up and you just do a divide to get what you times by to scale it up, then scale the other side up by the same amount. Okay? Now obviously sometimes you might be asked what an original amount was, in which case that's also easy. You can work out the scale factor here, and then you can divide to get that amount. Okay? Or it might be that you just write it the other way around. If we'd have known the 25 and 700, we would have just said, 25 and 700, and then this becomes 15. Or what's the scale factor? Well, what's 15 divided by 25? It's 3/5, so we times by 3/5, and actually because that's a fraction less than 1, that's why it's getting smaller, times by the same amount. So it's really flexible, as long as you have a vague sense of these two numbers go together, this number goes with this one, and I want to know what the missing one is. What's the scale factor? Do the same scale factor, and you shouldn't go wrong. Famous last words. If you do find you have any issues, then pop them down into the comments and I can have a look and let you know. But otherwise, cheerio.